Hello ASUonline MAT 117 students. This is Math Coach Colin, and this is a review of some topics in Objective 13 I noticed that a majority of students have not yet completed. The first topic we will review is writing the equation of a quadratic function given its graph. In this topic, you will be given a graph of a quadratic function with the vertex and one other point labeled. Using this given information, you will be asked to find the equation of the quadratic function. For this kind of problem, remember, the vertex form of a quadratic function is f of x equals a times the quantity of x minus h squared plus k, where a is not equal to 0. The vertex is represented by h, k. You substitute the coordinates of the vertex into the function, and using the other given point, you can solve for the coefficient a. Let's try an example. Find the equation of the quadratic function f, whose graph will be shown right here. You have the vertex 5, 4, and you have another point 6, 2. Start by substituting the vertex into the vertex form. F of x equals a times the quantity of x minus 5 squared plus 4, where we see 5 is h and 4 is k. Now substitute the other point in for x and f of x, and use the rules of algebra to solve for a. So we have this other point 2, substitute in here for f of x, which is also y. 2 equals a times 6, which is the x value of that point, minus 5 squared plus 4. Then after performing the calculation, we'll find that a equals negative 2. Therefore, your function is f of x equals negative 2 times the quantity of x minus 5 squared plus 4. This is our final function. This is how you find the equation of a quadratic function given a graph and some coordinate points. If the vertex has a negative x coordinate, don't get confused when you substitute into the vertex form. If the x coordinate of the vertex is negative 2, for example, when you plug this in, it is not x minus 2 squared, but it's actually x plus 2 squared. So don't get confused there. The next topic we will go over is word problem involving optimizing area by using a quadratic function. With this topic, you will be given a word problem describing a scenario in which you need to find dimensions of a certain shape to find the maximum area of the shape with a known perimeter. You can represent the sides of the shape with variables, and then you can build equations with these variables. In this topic, the equation you will be making will be a quadratic equation. Let's look at an example. Diane has 240 meters of fencing and wishes to form 3 sides of a rectangular field. The 4th side borders a river and will not need fencing. As shown below, one of the sides has length x in meters. And then there are 3 parts. Part A says we got to find a function that gives the area a of x of the field in square meters in terms of x. Then part B, what side length x gives the maximum area that the field can have. And then part C, what is the maximum area that the field can have. So you're going to use 3 sides of fencing and a known perimeter of 240 meters to find the maximum area. You are told to represent the 2 shorter sides with x, and it will help to call the other side y for now. Start by making this equation for the perimeter of the 3 sides. 2x plus y equals 240. You have the 2 x's and the y. So the sum of these should be 240. Now solve for y in terms of x. If we subtract 2x on both sides, we see that y is equal to 240 minus 2x. So for the first part, you are asked to find a function a of x that gives the area of the field as a function of x. You know the area of a rectangle is length times width, or x times y. So a of x equals x, y. You need this whole function in terms of x, so substitute your y into the equation. So this is equal to x times 240 minus 2x, which we earlier said was equal to y. Now we can simplify this to a of x equals negative 2x squared plus 240x. This is our equation a of x. A of x is a quadratic function with a negative leading coefficient. So this means that the graph opens downward and that the maximum point will be the vertex. The y value of the vertex will give you the maximum area of the rectangle. To find the x value of the vertex, use x equals negative b over 2a. From the standard form of a quadratic equation, you know that b equals 240 and a equals negative 2. Substitute these and solve for x. So x equals negative 240 divided by 2 times negative 2. After performing this calculation, we find that x is equal to 60. So this is the x value that maximizes the area. So now substitute this value of x into the function to solve for the maximum y value, or area value. We have a of 60 is equal to negative 2 times 60 squared plus 240 times 60. And after performing this calculation, we see that area, so a of 60, is equal to 7,200 meters squared. And this is the maximum area that the rectangular field can have. Remember that with these problems, the maximum value will be the vertex of the parabola. When you write your equation, you will usually get a negative leading coefficient. These problems are designed that way. If you had a positive leading coefficient, then the parabola would open upwards, and then you wouldn't be able to find a maximum area. The next topic we will go over is range of a quadratic function. With this topic, you will be given a quadratic function and asked to find the range of it. Remember that the range of a function consists of all the y values of the function. The graph of a quadratic function is always a parabola, and a parabola will always have a boundary in its range at the vertex, while the other end of the range is infinite. Let's look at an example problem. Find the range of f of x equals 3x squared minus 6x plus 1, and we'll need to write the answer in interval notation. First of all, we need to look at the leading coefficient. If it's positive, then the parabola opens upward. If it's negative, then it opens downward. This one is positive, so it opens upward. This means that the range will start with a finite value, which is the vertex, and then it will go up to infinity. The range consists of y values, so we need to find the y value of the vertex. We'll have to find the x value first, so use the x-axis of symmetry equation. X equals negative b over 2a. We see here that b is negative 6 and a is 3. So this is equal to negative times negative 6 divided by 2 times 3. And this simplifies to x equals 1. Now we substitute 1 in for x and the function to find the y value. F of 1 is equal to 3 times 1 squared minus 6 times 1 plus 1. This simplifies to negative 2. So the y value of the vertex is negative 2. This is the minimum y value on the graph, and then it opens upward to infinity. So your range is negative 2, comma, infinity. And negative 2 is a bracket because it's a finite value included, and infinity goes on forever, so it's not really a finite value, so we use a parenthesis. And this is the range of our quadratic function. Remember, if you are given a quadratic function with a negative leading coefficient, then the range is negative infinity to the y value of the vertex. So the next topic we'll go over is solving a quadratic equation with complex roots. With this topic, you will be given an unfactorable quadratic equation, which will have complex roots. And using the quadratic formula, you will find these complex roots. Remember the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Also, remember that a negative in a square root is undefined. However, it can be expressed as a complex number. The square root of negative 1 is equal to I. Let's try an example problem. Find the complex solutions of 7x squared plus 3x plus 3 equals 0. We see that a equals 7, b equals 3, and c equals 3. Substitute these into the quadratic formula. X equals negative 3 plus or minus the square root of 3 squared minus 4 times 7 times 3, all divided by 2 times 7. This simplifies to negative 3 plus or minus the square root of negative 75, all divided by 14. Or, with the square root, you could say this is equal to negative 1 times 75 and the square root. We can pull that negative 1 out of the square root as I. So, this is equal to negative 3 plus or minus I times the square root of positive 75 divided by 14. So now we can simplify the square root and find our final answers. We can simplify the 75 to 25 times 3. So we can pull the 25 out of the square root. So this equals negative 3 plus or minus, and then the square root of 25 is 5. So 5i times the square root of 3. That's all we have left in the square root, and the square root of 3 cannot be simplified any further. Divided by 14. And now Alex, they want you to write your answers like this. X equals negative 3 over 14 plus 5 square root of 3 over 14 times I, and then your other answer is negative 3 over 14 minus 5 square root of 3 over 14 times I. The I makes these answers complex. That's how you use the quadratic formula to find complex roots. Remember, the answers will only be complex if the part inside the square root is negative. Complex roots imply that the graph never actually crosses the x-axis, so there are no real roots.